Transfer of heat. You might have observed that a frying pan becomes hot when kept on a flame. It is because the heat passes from the flame to the utensil. When the pan is removed from the fire, it slowly cools down. Why does it cool down? The heat is transferred from the pan to the surroundings. That is, heat flows from a hot object to a cold object. In other words, heat flows from an object at a higher temperature to another object at a lower temperature. The flow of heat stops when the two objects attain the same temperature. Heat can be transferred from a hot object to a cold object in three different ways, that are conduction, convection, and radiation. In solids, heat is transferred by conduction. In liquids and gases, heat is transferred by convection. And in empty space or vacuum, heat is transferred by radiation. In this chapter, we will study conduction, convection, and radiation in detail. Let us start with the conduction. Okay? If we heat one end of a metal spoon by keeping it over a gas burner, we find that its other end also becomes hot after a while. In this case, heat is transferred from the hot end of the metal spoon to its cold end. When heat is transferred from the hotter end of spoon to its colder end, there is no movement of the material of the spoon from one end to another. Such a transfer of heat from the hot part of a material to its colder part is called conduction. Conduction is the transfer of heat from the hotter part of a material to its colder part without the movement of material as a whole. In all the solids, heat is transferred by the process of conduction. Here are some examples of transfer of heat by conduction from our day-to-day life. A cold metal spoon dipped in hot cup of tea gets heated by conduction. A frying pan kept on a gas stove transfers the heat of gas burner through its metal bottom by the process of conduction. We will now describe an activity to demonstrate the process of conduction of heat. Take a flat aluminum rod and fix some small iron nails on it with the help of melted wax. This rod is clamped to a stand. Then heat the free end of the aluminum rod by keeping a burner below it. We can see that the iron nails attached to the aluminum rod with wax start falling one by one. The nail attached nearest to the heated end of rod falls down first, and then the next ones fall, but the nail attached to the clamped end of the rod drops last of all. These can be explained as follows. The burner is placed below the left end of aluminum rod. So the left end of aluminum rod gets heated first. Now the left end of aluminum rod is hot, but the right end of the rod is cold. So heat is now transferred from the hotter end of aluminum rod to its colder end. As heat travels from the left side to the right side along the aluminum rod, it melts the wax which holds the nails. Due to this, the nails fall down one by one. From this activity, we can conclude that heat is transferred from the hot end of aluminum rod to its colder end by the process of conduction. The transfer of heat by the process of conduction takes place only in solids. This can be explained as follows. In solids, the particles are closely packed together. During conduction, heat is transferred from particles to particle by means of back and forth vibrations of the particles caused by the heat energy. The particles of a solid remain at their fixed positions. There is no actual movement of the particles of the solid from its hotter end to the colder end during the conduction of heat through it. Some materials conduct heat easily, whereas the other materials do not conduct heat easily. So, on the basis of conduction of heat, all the materials are classified into two groups: good conductors of heat and poor conductors of heat. It will become more clear from the following activity. Take a beaker and fill it half with hot water. Now take two spoons, one made of metal and the other made of plastic. Place the metal spoon and plastic spoon in the beaker containing hot water. After about 2 minutes, touch the top ends of both the spoons with your hand. You will find that the top end of metal spoon feels hot, but the top end of plastic spoon does not feel hot. This is because heat from the hot water flows easily through the metal spoon and reaches its other end. But the heat does not flow easily through the plastic spoon, due to which its other end remains almost cold. This activity tells us that metal spoon is a good conductor of heat, whereas plastic spoon is a poor conductor of heat. Those materials which allow heat to pass through them easily are called good conductors of heat. All the metals are good conductors of heat. For example, the metals such as silver, copper, aluminium, iron, mercury are all good conductors of heat. All the objects made of metals and metal alloys are good conductors of heat. Those materials which do not allow heat to pass through them easily are called poor conductors of heat. The materials which are poor conductors of heat are called insulators. A poor conductor of heat is an insulator of heat. Some examples are plastic, wood, paper, cloth, leather, cotton, thermocol, rubber, bricks, cork, bamboo, glass, water, air, etc. In general, liquids are poor conductors of heat and gases are very poor conductors of heat. For example, water is a poor conductor of heat and air is a very poor conductor of heat. The materials which trap air such as cotton, wool, fur, feathers, fiberglass and plastic foam, etc., are very poor conductors of heat. That is, materials having trapped air in them are excellent insulators of heat. Let us know uses of good conductors and poor conductors of heat. We make use of good conductors of heat as well as poor conductors of heat in many ways in our daily life. Good conductors are used to carry heat quickly where it is wanted. Poor conductors are used to stop heat from going where it is not wanted. Some of the examples are the cooking utensils are made of metals. This is because metals are good conductors of heat which transfer the heat from the gas stove quickly to the food placed inside the utensil. The cooking utensils are provided with handles made of plastic. This is because plastic is a poor conductor of heat. A plastic handle prevents the heat from hot cooking utensil reaching our hand so that we can lift the hot cooking utensil safely from its handle. There is no risk of burning our hand. You might have seen some stainless steel frying pans are provided with copper bottoms. The reason for this is that copper metal is a much better conductor of heat than stainless steel. In the previous class, you have learned about thermometers. Mercury metal is used in making thermometers because it is a good conductor of heat. Some more examples. The handle of a soldering iron is made of wood or plastic because wood or plastic is a poor conductor of heat. The wooden handle does not conduct heat to our hands so that we can hold the hot soldering iron safely from its handle. Why do people wear woolen clothes in winter? This is because woolen clothes keep us warm during cold winter days. How does it happen? Wool is a poor conductor of heat, due to which woolen clothes stop the flow of heat from our body to the cold surroundings. Besides this, there is air trapped in between the fibers of the woolen clothes. Air is a very poor conductor of heat. So, the air trapped in fibers of woolen clothes also stops the flow of heat from the body to the cold surroundings. Since our body does not lose its heat, we feel warm on wearing woolen clothes in winter. The feathers of birds keep them warm in cold weather due to air trapped in them. Air, being a very poor conductor of heat, prevents the body heat of birds from escaping to the cold surroundings and hence keeps the birds warm in cold weather. Similarly, the animals having fur, such as polar bear, keep warm in cold weather because their fur traps a lot of air, which is an excellent insulator of heat. It is possible now to construct houses and other buildings in such a way that they are not affected much by the heat or cold outside. This can be done by constructing the outer walls of houses by using hollow bricks which contain trapped air. Since the hollow bricks contain very poor conductor of heat, that is air trapped in them, the walls made of hollow bricks will neither allow outside heat to come in during summer nor allow inside heat to go out during winter. This will save a lot of energy. What we are using to keep houses cool or warm. Is it clear, children?